Now let's open two 2D AVI files, each with a different view of our reference frame. In order to accurately track points in 3D, we must first inform the system of the camera's locations. We do this by identifying points whose coordinates are already known. In our example, we have 8 markers filmed from 2 different camera views. We are going to use the static DLT calibration method, but it is possible to perform a static and one-wave calibration. The coordinates of each marker have been entered here. We can create our own calibration frame using markers and then measure the 3D coordinates of these markers as accurately as possible. A calibration frame must have at least 6 markers. More are recommended for best accuracy. We need to digitize the marker points on the frame in both videos. Pressing the Track File and MaxTRAQ button will open MaxTRAQ 2D, and we can digitize the 8 points on the frame. To see more details on digitizing, please see the MaxTRAQ 2D video. Once we have digitized this video, we can close MaxTRAQ 2D and track the second AVI. Remember to track the markers in the same order in both AVI files. Identifying the points in a different order will result in an inaccurate calibration. If our cameras are not hardware synced, we will need to synchronize them in MaxTRAQ. To do this, we will need to record an event where we capture the video. The event can be, for example, an LED flash or a ball drop. In MaxTRAQ, we can then set the synchronization point by pressing this T0 button here. This will set the current frame as the first frame. Repeat this step for each camera to synchronize them at the same start point. With the 2D reference calibration files digitized, we complete the calibration process with a simple click of the Calibrate button. If we now look in the Calibration Status tab at the bottom here, we can see the cameras have been successfully calibrated and the X, Y, and Z position of each camera relative to the 000 point or origin of the reference frame has been calculated. The merit value represents the average error in system units. This value depends on the cameras and lenses being used and the measurement volume. Once the camera system is calibrated, the cameras should not be moved. If they are accidentally moved, they need to be calibrated again. The merit value in the DLT calibration does not directly reflect the error. However, if it is very high, then there is a problem. If this value is above 10, then there is a problem, and you should recalibrate. Normally it is below 2. It is also important to check that the calculated camera positions are reasonable.